morning, everyone. Can you hear me in the back? Can you hear me? All right, excellent. So, my name is Guy, and my first memory is from when I was 4 years old. Oh, by the way, if you haven't understood by now, this session is going to be in English. Okay? So, I was 4 years old. I was in the kindergarten. It was Glantser, and it was Purim. For those of you who might not know what Purim is, it's a Jewish holiday. We wear costumes. And this one, I love Purim. I love to wear costumes. And it was Purim party in the kindergarten, and I wore a magician costume, and we were sitting in a circle, all children, and then each one on his own turn. It was my turn. I stood up, and I did like this. I raised my hand, put it in my pocket. Ta-da! And then all the kids went, wow, amazing. And I was really excited. And at that moment, I knew that when I grew up, I want to be a school teacher. Then I grew up, and I became a DBA. And not so sexy, I know. I've been doing this, not magic stuff, DBA stuff, in the past 20 years. With SQL Server, with some other things, but mainly with SQL Server. And I'm an MVP, Data Platform MVP. And I realized at some point that I'm actually a magician. I'm fulfilling my dream every day. Because sometimes, it happens quite a lot, a client calls me, use my magic show DB. And the client says, we have that store procedure, it runs really, really slow. It looks like this. Can you see it in the back?
No.
No, okay. Can you see it now?
No.
Not alive.
You see it now? Alright. So they do something like this. Do something really important but really slow. Okay? And it takes time. And they say it sucks. It runs for a long time. Can you do something about it? And I come with my outfit. Alright? This takes about how much? 13 seconds. I do some stuff, some magic. Then I run this one. This is my version. It runs instantaneously, right? It's like magic. And for most clients, this is magic. They go, wow, how do you do that? Stuff, right? So yeah, I do magic every day, and I'm here to show you some of this magic. Now, not like a regular magic show. I'm going to teach you how to pull those magics, how to do them yourself. Okay? But, oh, I forgot, before I do that, to make it more interesting, here's the real magic. I need a volunteer. The first time. Don't be afraid. Yes, it's you. So I have a deck of cards here. I'm not that good. Try to look professional. Okay? Like this. Now you choose any card. Keep it for yourself. Don't show it to me. You have your card, right? Put it right there. Now, I have an envelope. A blue envelope. You put the card in the envelope. I'm not looking. It's there. Seal the envelope. Whatever. You keep it. It's yours. We'll get back to that later. Alright. So, I have magic 1, magic 2, magic 3, magic 4, magic 5. And I have 45 minutes. So good luck to me. Let's start. Magic number 1. Wow, that's big. For all magic, I need set statistics IO to look at the logical reads and the actual execution plan. And first, I want to show you some data that I'm going to use. I have a card deck table, which is 52 rows, all different cards. And the main table I'm going to use is blackjack hands. So this is around 10 million rows, all hands of blackjack, and it looks like this. Okay, so we have the first two cards like that, like 6 heart, jack heart, and so on. And we have the game time, when was the game played. We have lots of null values. This is on purpose, of course. For some games we have the game time, for some we don't. Okay, so this is my data. And my first magic is about scalar user-defined function. Now Brent talked about that. I want to add some more. Okay, so I have a function here. It takes daytime value, daytime 2, returns varchar 7, and what it does, simple case, I want to return the date part, because in the casino, it's blackjack, right? In the casino we have 3 shifts, morning, noon, and evening shifts, and I want to know for each daytime value what shift it is. So I do a case if date part hour is between 0 and 7, it's morning, and so on. And then I just return it. Okay, scalar function. I use the day part a lot in my database, so it makes sense to create a function for it. And now what I want to do, I'm going to do an aggregate, group by the day part, okay? And I want to just count how many blackjack hands do we have in each shift, okay? That's it. It'll take some time. Now what's the problem with scalar functions? So it's row by row, that's one thing. For each row, we have 10 million rows here. For each row, we have to call the function, run the function body, go back again, again, and again. It's like a cursor, right? That's one thing. What else? There's a lot more. The query that uses the scalar function will never go parallel. You cannot have a parallel plan, only serial. This can be a big thing. Okay? We have to scan 10 million rows, like in this case, we have to do it serial. I might have 32 cores on my server, but I cannot use it, just one. Okay? Another thing, if we look at the execution plan, in a second hopefully, we see nothing about this function. The execution plan tells us nothing about the real cost of what's going on within the function, or what actually is happening in there. Okay? So we're done. It took 49 seconds. Okay? Don't care about the results. Let's look at the plan. Okay, so we have the index scan. We scan 10 million rows for our blackjack hands table. We have this innocent looking compute scalar operator which has only 1%. But what it does, it calculates expression 1001, which, if we go here, happens to be calling our function, okay, the date part function. So actually, most of the work happens here, but we don't know about it. We can't see it from the execution plan. We also can't see what exactly the function does. Okay, that's another thing. And as you can see, it's serial. And what else we have here? Brent talked about this as well, the memory grunt. Okay? Again, one of the problems with functions, we don't really know what it does, how much data it returns. SQL Server cannot estimate correctly the memory it needs for the query. In this case, we are doing a group by. Okay, now, as you know, we have 3 shifts. We also have now, we have 4 rows in the result, just 4. Okay? If we look here, the estimate is this, around 1 million. Okay? Because the function is a black box, we don't know what it returns. SQL Server estimates, I don't know how, whatever. 1 million rows, it grants a lot of memory for that, which we don't need. It's a waste. Okay, so lots of problem with scalar functions. Took 49 seconds. What can we do about it? Before 2019. Okay? I mean 2017, by the way. So one thing, we can just ignore scalar function altogether. We can just not use them. Okay? We can do something like that. I have a CTE. I take the logic from the function into the query itself. Okay? And then I put everything in the query itself. So I'm not calling the function. I'm doing essentially the same thing. Group by, etc. But the logic, the case expression, is now inline inside the query itself. In this case, in the CTE, it takes 3 seconds instead of 49. Amazing! By just doing that, okay? By just not calling the function. And we get all the things that we didn't have before. Now we have a parallel plan. We scan the 10 million only parallel. We can see exactly what's going on. We see the real cost. It runs really, really fast. The problem is, we want to use functions. It's a good thing. Okay? It's reusable. It's maintainable. It's documentable. It's all kinds of Okay? It's a good programming practice, but it's bad for performance. So what do? Next option, something that Paul Wright wrote about a long time ago, I learned from. There are 5 metadata properties that you want to look at about functions and other models, actually. Each function can be either deterministic or not, precise or not, and so on. If we look at this function, you will see that it's not deterministic. Just taking a data value, doing a simple case, why not? It's not precise, come on. It's not system verified, that's interesting. User data access true, I'm not accessing any table, you know that, it's a simple case expression. And system data access true also, what's going on? So we have this with schema binding clause. You familiar with that? We can add with schema binding to each model, including functions. What it means, it binds the function to the actual tables or objects that the function accesses. Okay? This means if I have this function with schema binding, I cannot alter the table that it references. If you try to add a column, for example, you get an error, it is bound to a function or whatever. Okay? It's actually a good thing, a good practice. You might want to use it on all your models. It might be a problem if you have some deployment scripts or you're using third-party tools. Sometimes might break your script because the function is created before the table and then the table cannot be altered and so on and so on. So you need to be careful there. But the problem is if you don't put with schema binding, SQL Server skips validation. It does not look at the code of the function. It doesn't know what's going on. It assumes the worst. The worst is not deterministic, not precise, not system verified, accessing data, accessing system. So that's a default if you're not using schema binding. And the thing is, this is what I learned from Paul White, that if you add with schema binding, okay, I'm just doing this. That's the only difference. Okay, with schema binding, now it's deterministic, precise, and so on. I will show you. Oops. Much better. Okay? So now SQL Server knows deterministic, precise, and so on, and it can do some optimizations which it cannot do with non-schema bound functions. Now, I'm not sure if this is going to be very meaningful. It'll take a while, but I want to move on. Okay, we'll get back to this when it finishes. In the meanwhile, I want to show you something else. You saw there are many null values in the game datetime column. Now, for each null value, we still call the function, run the logic just to return null. Okay, because if you do the case expression on the null, you get null back. We have this other clause, returns null on null input. Okay, which is very powerful in cases like this one. I have around 90% null values in the table. Okay? What it means, for null values, don't even call the function, just return null. If the logic of your function is to return null, and the input parameters are null, use this one. Okay? This can really boost performance. I'll show you. First, we had 49 seconds before. Looks like we didn't do nothing with schema binding. 48. I saved 1 second. Okay, so in this case, it doesn't do much. In some cases, it really depends on how the query is written. In some cases, by just adding with schema binding, even though the function does not access any real objects, will make it run really fast. Okay, try it. Let's move forward. I want to add with schema binding and returns null on null input. Let's see what happens now. So it's done. 10 seconds. Now that's a real improvement. Of course, as we have more null values, the improvement will be more dramatic. Okay, but I learned this just a few months ago. I think I wasn't aware of it. It was there forever, since ever. Okay, so use the return null null input. That's important. Next thing, we have memory optimized tables. We also have natively compiled store procedures and functions. As far as I remember, this was introduced in 2016. The ability to convert scalar functions or to write scalar functions as natively compiled. So for that, we need to add a file group that contains memory optimized data and add a container in the database to support this. Let's drop the function and create a new one. Now I have to add native compilation. Begin atomic. This is the syntax for the natively compiled function. And oops, we get an error. We cannot use return null and null input with a natively compiled function. Too bad. But I still want to try it. Okay, so I'm going to do it without the return null and null input. Now, being a natively compiled function, what that means, run the same select statement, it means that SQL Server, when I create a function, creates a DLL. It compiles the function, creates a DLL, and now at runtime, it just uses the runtime code without interpreting the code. Okay, so it can really improve performance. And again, in this case, I'm using it without having any memory optimized tables. I don't really care about memory optimized tables. I just want to improve my function. Okay, so it should be better. Let's see. It's worse than before. We had 10 seconds with the returns null or null input. Hopefully, it will be better than 49 seconds. Maybe I do this. Right. Okay, not such a big improvement. 48, just like before. Okay, again, it really depends on what you do on your function, on your workload, on your server hardware, and so on and so on. Sometimes the improvement will be better, sometimes not. Try, test, play with it. Okay, but what I want to do, I want to have a natively compiled function, but also ignore the null values. So I can do it myself. I can add a CTE and then say select case. When it's null, just return null, otherwise call the function. So I can skip it myself. So now it's a natively compiled function and skipping the null values. It's going to take 8 seconds. Great, better. Okay. Even better, what you can do, we can inline the function. Now, Brand mentioned it in 2019. Microsoft does it for you. Okay. In 2019, you have a scalar function in most cases, or many cases. Okay. Microsoft will do it for you. SQL Server will inline the function, and I will show you how to do it yourself in 2017 or earlier, or even in 2019, because like Brent said, sometimes you don't want it to happen automatically. Okay. So in this case, what I do, it's a different function. Now it returns a table, still schema binding. Okay. It's a single select statement. It returns a single column and a single row, okay, with the same case expression. So it does the same logic, but now it returns a table with a single value instead of a scalar value. And now I also have to rewrite my code. This is the cool thing. In 2019, you don't need to do anything. It just happens for you behind the scenes. I have to use now cross-apply because it returns a table, and for each row from this table, I call the function. Okay? Now it might sound to you like the same problem. It's row by row, but no. Now it's inline, so the optimizer now can do its magic and produce the appropriate join operation between them, and it can run much faster. It's not going to be actually row by row. If we do it now, just 3 seconds. Okay? Just like we did before when putting the code inside the query, but now we can still have the function. We can reuse the function. So we have the function logic, we have the good programming best practices, and we can get good performance as well. Can we make it even faster? Another magic I want to show you. This time I'm going to create a completed column, okay, with the exact same logic. Now it's going to be in the table. So instead of using a function, assuming I'm using this logic only for this column, for this table, in many queries, let's put it in the table itself. So here's a computed column. It doesn't have to be persistent. And I'm going to create an index on the computed column. So now I will also say, I don't need to call the function anymore, because we have a column now called dayPart. I save the time having to calculate dayPart for all 10 million rows. Okay? Let's just finish creating the index. Alright, let's do this. 1 second. Okay, really fast. We started with 49 seconds, now just 1 second. And we have the logic inside the table, we can reuse it. We have just a single column name we can use instead of a function, etc., etc., etc. Okay, so you have all the options there to improve those. And again, in 2019, you have it out of the box. Microsoft does it for you. SQL Server will inline your scalar functions in many cases, but it's not always good. Sometimes you might get worse performance. You really need to troubleshoot and see what's going on behind the scenes to understand what's going on. Okay? And if it's not good enough, do one of those. Any questions? so far? Right. Let's move on. Yeah. Sorry? I'm not sure that they can see it. Let's try again. Let's put here 300. Is that okay? In the back? You see it? All right. That's good. Let's close this one. Move on to magic number 2. Alright, so look at this one. The purpose of magic number 2 is to demonstrate a different type of magic. Okay, sometimes you need to be very technical to pull your magic. Okay, sometimes you need to be creative. You need to think out of the box, like in this case. Look at this one. I want to look at the blackjack hands again, group by the hands, 2 cards player gets, and I want to look for all the combination of 2 cards where the dealer, for all games, had only 1 card. Okay, so for example, I have 7 and queen, 7 club, queen, spade, whatever. Okay, for this combination, for all games, the dealer always got the same card. That's what I'm looking for. Okay, some statistics, right? So count this thing, dealer card equals 1. If we look at this, okay, so they're known. I don't care. Let's look at the plan. So what happens in the plan? We have an index scan. We scan the entire table, of course. Then we have a hash match partial aggregate. Why partial aggregate? Because it's parallel. Okay, so we have 4 threads in my case. We have 4 threads. Each thread does its own. It's a partial. Then we have to aggregate all threads together. So we do a repartition strings. Okay, we repartition the rows between the threads. Then we do another aggregate. Then another one, and then another one. You have 4 aggregates. What's going on? Okay, so actually what SQL Server does, in order to do this count these things equals 1, it does this. Okay, it's like a derived table, group by player card 1, player card 2, and dealer card 1. Okay, this is the first partial aggregate and aggregate, and then group by again player card 1 and 2, and having count equals 1. Think about it. It's the same result, different approach. This is what SQL Server does behind the scene. Okay, so we have eventually we have 4 aggregate operators. If I run this, we get the same result with counting. We get the same plan, 4 aggregates. Okay. Now I know it runs quite fast. This is not the purpose of this demo. Okay, think about a really, really large table. In some cases, this might really make a difference. What I want to do is to reduce the number of aggregates, improve plan, improve performance, improve CPU in this case. Okay, and just one example of how you can be creative, we can do this. Instead of saying count distinct equals 1, having min equals max. Okay, so if for each combination, for a combination of 2 cards, the min and max are the same, it's like saying we have just a single value. Alright? Same thing, but now, for this one, SQL Server can use a single aggregate. Okay, so again, it's still 2 because of the parallelism, but that's fine. We now have a single aggregate on the 2 cards. We don't have to go through the 2 phases. Okay, so it's a little bit better. Again, depending on the size of the table and the complexity of the query, it might be much better. So again, just as an example, I know it's a niche, okay, to give you an idea of some cases where you need to be creative. Think out of the box. Okay? Any questions? Sorry? No, minimum can be everything. But if the minimum and the maximum are the same, it means there's only one value for that group. So it's just like saying count distinct equals 1. Right. Moving on. Okay, so I have a store procedure. It's called count hands with specific cards. What I'm doing here, you know what I'm going to talk about, right? I declare a table variable, local table variable, called random cards, just the card ID. And then I'm going to select 10 random cards from my card deck. Okay? Let's pretend it's meaningful. And then I'm going to use this table variable. I'm going to show you the 10 cards. And I'm going to use this table variable and join it to the blackjack hands and I want to look for all the hands where one of the cards, either card 1 or card 2, is in the list of 10 random cards. Okay? Meaningful process or something, whatever. That's what I want to do. Okay, so we get 10 cards. Okay, a random list of 10 cards, and now we perform the join. Okay, so we do the join. We have 10 rows in the table variable. And let's make sure that we are on the same page. What are the problems with table variables? What's the main problem? No statistics, all right? We have no statistics. SQL Server maintains statistics automatically for tables, regular tables, for temporary tables, not for table variables. No statistics at all. And the optimizer has to assume something about the number of rows. It took 16 seconds. We go down here. So, estimate number of rows will always be 1 for a table variable. In this case, the actual number of rows is 10. Okay, just 10. It could be 100, 1 million. It will always be 1. And because it assumes it's 1, let me scan this 1 row and use a nested loops inner join, which means for each row do this, but it's just once, right? So who cares? And I'm going to do an index scan. I'm going to scan the entire blackjack hands table, 10 million rows, just once. No, 10 times. Okay? And it takes 16 seconds. Big mistake. Okay, so that's the problem with table variables. I see it all the time. This is one of the magics I really love to do. Okay? I go to a client, they say we have performance transfer forever, do something about it. I take a look, I do something like this. Honestly. Then I see this, say, okay, I know what the problem is. Just replace it with create. Okay, the name of the temporary table, replace everything, run, boom, great. Ta-da! I love this. Okay, it happens to me a lot. So yes, you can replace it with a temporary table. Something else you can do. Where is it? Oh, right here. You can add option recompile. That's another magic I really love. Option recompile is like a magic word. You just put option recompile, magic happens. You don't need to change anything else. Okay? What option recompile does, as opposed to other things, it recompiles the statement, this specific statement, at runtime. It's really important. It happens at runtime. Because at runtime, SQL Server knows a lot of things. Okay? It knows the values of the local variables. It knows the actual current values of parameters if you change them. It knows the number of rows in table variables, for example. This is good for our case. It can simplify lots of queries. I will come back to this later. Okay? And it really does magic. You can take a very complex query with all kinds of problems, table variables, local variables, parameter sniffing issues, all kinds of issues. By just adding option recompile, boom, everything is solved. Great. Problem. Who here went to Brent's pre-con yesterday? Okay, so Brent talked about it. Few problems with option recompile. One of them, it recompiles each time. Don't do it in your OLTP busy production server. It's very dangerous for your CPU. Okay? If this stop procedure runs many times per second, this can be really dangerous. Okay? Be careful. Big disclaimer here. But if you run a data warehouse and only a few users use it, and they only run heavy queries once in a while, this is a great thing. I want for each report running to spend a few more milliseconds, I don't care even if it's 2 seconds, to get the best plan and then run the report. It's a good thing. It's a great thing. Okay? But this is one thing. You need to understand the workload and specifically the frequency of running this specific statement or stop procedure. Okay, this is one thing. The other thing, when you recompile each time, you don't have the plan in cache, it's not reused, and you don't have statistics about it. Okay? So if you have some monitoring, troubleshooting mechanism, you want to look through DMVs and stuff, you will not have this information. This can be important, depending on, of course, your environment. Sometimes it's very important, sometimes I don't care. I just want good performance. Up to you. Okay? You need to be aware of that. And the third thing, Brent mentioned yesterday, there were some bugs in the past with option recompile, really serious bugs, where you can get the results of someone else running another query. It's really bad. It was in 2008, I think, 8 or 12. 8 and then 12, I think. Okay, they fixed it a long time ago. Of course, if you run it today, 2008 or 12, make sure you're on the latest service pack or community update. Okay, so the bug is fixed. So I have to disagree with Brent on this one. Sorry, Brent. I don't think this is an argument against option recompile. Everything can have bugs. Okay, it's just like saying don't use group by. Maybe there's a bug someday. So yeah, I know. Group by is something else. Nobody touches this code anymore. Option recompile had already 2 bugs in the past. Up to you. Okay, make your decision. But I recommend people to use option recompile. Of course, considering the 2 factors I mentioned before. If you have a data warehouse, not an OTP-based environment, I think it's a great thing. And for this example, I'm going to add option recompile. And again, the nice thing about it, it's really like magic. You just add the magic words, and that's it. Execute. Instead of 16 seconds, it now takes 3 seconds. Okay? Because now it's here. The optimizer knows that we have 10 rows. Okay? Next to our 5, and because it's 10 rows, we have a different plan now. It's not nested loops, okay? It's nested loops, but it's the other way around. Okay, we start from the big table, we scan it only once, okay? Then we do the group by, which is the aggregate, the count in this case, and only then we do a nested loops to our table variable. Okay, so it's a much more efficient plan in this case because the optimizer knows the number of rows. Okay, so this was one option. Okay, of course, instead of that, you can just replace the table variable with a temporary table. Now, a temporary table might have some issues in some cases. Okay? Since a temporary table has statistics, it also means it has recompiles. But for most cases, really 99.999% from my experience of the cases, it's a good thing. You want those recompiles. It doesn't recompile every time. It recompiles only when the number of rows in the table changes significantly from the previous run. Okay? And then you want it to recompile because the previous plan is not good enough. So it's a great thing. Of course, for some edge cases, if you run these stop procedures many times, and the number of rows changes all the time, this recompile might kill your server. But this is really an edge case. You should be careful, of course, and test it as always. But again, for most cases, I recommend use temporary tables, don't use table variables. So by just replacing table variable with a temporary table, we get more or less the same results as with option recompile. 3 seconds, and we get the same plan. Okay, this is the temporary table. We know it's 10 rows, same thing. All right. Like Brent mentioned, 2019. We have a new feature called deferred compilation for table variables. We have that today for temporary tables. Deferred compilation means in the first execution of your stop procedure, SQL Server will wait until you actually use the temporary table and only then compile the next statement using the temporary table. Now it knows the actual number of rows. Okay? That's a good thing. Only the first execution. In 2019, we have that for table variables as well. This is why only for the first execution you get a compilation of the statement after you have rows in the table variable, just like using option recompile actually, but only for the first execution. From that point, you're using the same value, which might be good, might be not so good. Okay? But this is how it works in 2019. Any questions? It's too quiet. Yes?
One mentioned you can't use a temporary table in functions.
True. You cannot use temporary table in functions. That's all I can say. But again, depending on what function you're using. Okay, if it's a scalar function, probably. Okay, then go back to Magic 1, see what you can do about it. What are the options there? Okay. If it's inline, then you can't use table variables anywhere. Just single select. It's good. All right. Magic number 4. Okay, let's take a look at this one. I want all the hands where the dealer card was 52, which is ace spades, and the player card was any one of those, jack, queen, king, or ace spades. Okay, player card 1 specifically. Give me all those hands. So there were like 17,000 hands like this, and here's the plan. Let's look at the plan. We have an efficient index seek, which is also a covering index, no lookup. It's great, isn't it? Right? Index seek, excellent. Runs very fast. Let's see what's going on here. So the seek is actually, by the name I can tell you that this index is on dealer card 1 only. Okay, it's sorted by dealer card 1, and we have as included columns player card 1, 2, and game day time. It's a covering index, but it's sorted by dealer card 1. Since it's only dealer card 1, we have a seek predicate only on dealer card 1 equals 52. And then we add a residual predicate, another predicate. We're checking each and every row coming from that index to make sure that player card 1 is between 49 and 52. Okay? And this gives us 17,000 rows. But look at that. The number of rows read is 200,000. A lot more. Why do we need to read so many rows just to get 17,000? If we look at the I/O, in this case, it's 654. Now, that's not much, but again, just for the sake of this demo, imagine it's a lot. We want to reduce that number. Okay? If this were a much larger table, this would be a very large number. So, what we can do in this case, that's a different demo. Just replace the between, I had a between here, okay, 49 and 52. I'm going to replace it with in. That's the same thing, isn't it? Usually, what do you do in those cases? Between or in? What do you prefer? I heard all kinds of answers.
In will be
Let's see what happens when we do in.
accurate.
Okay, it looks the same. Look at this C predicate now. Okay, so now we have a different index. Okay, we have an index on player card 1 and dealer card 1. This is a composite index, which should be exactly what we need. Why SQL Server didn't use this index before? Okay, so if we add an index hint and force it to use that index, then now you can say that we have a seek, but because we have between, if you think about it, we start from 52.49 until 52.52. We have to scan, we do a seek, but then we scan a lot of rows. We have to scan the entire range, and to get out, only those with dealer card 1, 52, here. So in this case, it will even be worse, the number of rows that we need to read. By just replacing it with in, since now it's 4 distinct values, now we use the same index, but now we have 1, then 2, then 3, somewhere there's 4. We have 4 distinct seek operations. Instead of scanning a range, we do 4 specific, very precise seek operations, and now the number of rows is exactly what we need. We only read the number of rows we need to read, okay? And we save a lot of I/O. Okay? I wish the optimizer could do it by itself, understand that it's actually the same thing, but it doesn't. So we need to help and do some magic. Okay? So notice those cases. By the way, sometimes between will actually perform better than in. It really depends on how the indexes are created. Okay? You need to design your indexes well to match your queries, and of course, write your queries in an appropriate way. Any questions?
If I have a range of many,
Okay.
let's say 100, if I use some query to create it for me,
As far as I remember, if it's up to 64 values, okay, we'll use different seek operations. More than 64, it will create a temporary table in memory. Scan that table from a join table. It always depends on density. Yeah, I agree. The performance here depends on density, of course. How many rows you have for each unified. Yes. More questions? Right. The last magic. the last magic, I want to return to my favorite magic, option recompile. So in this case, I have this procedure, single parameter dealer card 1. I want to retrieve, what is it, top 10,000 rows from my table, where dealer card 1 is this, or the parameter is null. Okay, this is classic. We see it a lot. So we have a parameter. We have the default value of null for this parameter. And what we mean is, if you want to filter by dealer card 1, give me a value, I will filter by it. If you don't want to filter by that value, that's fine. Just don't pass any value. I have a default value of null here, and in my query, I do this. Either I filter by this, or if it's null, it will always be true, just scan the entire table. Okay? We filter without filter. Sometimes we have multiple parameters like that. We have all kinds of combinations of queries doing that. And the problem is, the optimizer doesn't know how to handle this situation. Let's execute with some value, 9 for example. Okay, so again, it runs very fast because it's a relatively small table. But the problem here, we have an index on dealer card 1, okay, but we get an index scan and not an index seek. Okay, so we scan a lot of rows, we're not doing the seek. And this is because of this statement. The optimizer doesn't know how to handle this case because it needs to prepare a plan that can be cached and reused for different values, whether it's null or not. It will just put a scan on the entire table. Okay, not good. One option we can do, we can use the isNull function. Okay, so instead of doing that, I'm doing this, where dealer card equals isNull, the parameter, or itself, which is always true. It's the same thing, just written in a different way. Whoops, no way. What happens now? It's a different plan, because this, although it's the same thing, for this statement, SQL Server estimates a different number of rows. Okay, I didn't show you before. This time, if we go here, this is the estimation, the number of rows. This is 10% of the table, while the actual number of rows is this. Okay, so we get a different plan, but still, we have an index scan. I want to seek. Okay, still not good. Doesn't really matter if it is null or coalesce or the previous example. Now, let's add option recompile. Okay. So one of the things option recompile does, not just knowing the values of parameters and so on, also it can simplify the query. In some cases, it will be dramatic. Because it happens at runtime, the optimizer knows that in this case, the value is not null. Okay? So it can just remove this from the query. It becomes just this. This is something that is very simple. We can use an index seek, etc., etc. Okay. So by just adding option recompile, you can make very complicated queries quite simple. So now we get an index seek. Okay, much better. IO, so on and so on. So again, option recompile, magic, but be careful. If it's a busy system, busy environment, OTP, the stop procedure runs many, many times, you need to be careful there. Okay, maybe it's not the best option for you. Another option, if you can't use option recompile, because it happens a lot, is to use dynamic SQL. Okay, so in this case, I'm going to dynamically build a statement, and I'm going to add here, only if dealer card is not null, I'm going to add this. And I actually have an inner parameter inside the dynamic batch, okay, with the same name in this case, but I only add this if the value is not null. If it's not, I'm not going to have a where clause at all. Okay? And then I have to define the parameter I have inside the batch, and then I run it with sp execute SQL statement, the parameter definitions, and I pass the parameter itself. Okay? The inner parameter takes the value from the external parameter, the procedure. And the thing here is now we get an index seek, of course. We run a statement that includes only dealer card 1 equals dealer card 1 without the or, and so on and so on. Okay? So again, for this we can do compilation, we can use parameter sniffing, we can get the index seek. Questions? Yes.
מה שאתה יכול גם לעשות זה להוציא את איפה שכתבת את הקייס, פשוט לשאול if בהתחלה, ואז בסוף הוא יעשה SQL.
Which case? This one.
כן.
Do what?
אתה יכול לשאול את זה לפני שאתה מריץ את השליפה בכלל, ואז אם כן, פשוט תשלוף לי את כל מה שאתה רוצה.
If instead of case. Okay, so what you were saying, instead of case, I can do an external if statement. If it's now, do this statement, otherwise do that, right? Okay, so that's another option. Yeah, absolutely right. Yes.
You put the option recompile in the end of the query. There is a difference between option recompile on the query on all the store procedures?
Oh, absolutely great question. The question was, what's the difference between option recompile here, or if it's a store procedure, we can do with recompile here. Okay, two options. What's the difference? Okay, so with recompile here, it's at the store procedure level. It recompiles the entire store procedure each time. If the store procedure has 100 statements, it will have to recompile everything each execution. If my problem is only with the third statement, it's a waste of resources. Okay? Option recompile only recompiles a specific statement, okay, so it's better. But the more important thing, option recompile, like I said before, happens at runtime. This is where the magic happens. With recompile, this one happens at compile time, before even starting to run the store procedure. So I don't know nothing about whether it's null or not, local variables, stable variables, and so on and so on and so on. So all the optimizations I demonstrated will not happen with recompile, only with option recompile. Right? What else? Okay, so this was 5 magics out of many I have, and we go back to you. Okay, you have the envelope? Open it, please. Don't show it to me. I will do this. No, it's called demo magic. Okay? You have your card?
Left.
You have your card? Wait out. Don't show it to me, show it to them. Here is your card, 9 club, right? I don't really know how to do magic. Thank you very much.